Hello, I'm wanting to provide a report on the BNSF Memphis Crane ID G868. The layout of the crane is such that it has 6 wheels on each bogie set and with 4 sets of bogies for a total of 24 wheels on this crane. On the left on the setup, you can see our setup the way we had it. The R1, rail 1 side was on the east side. R2 wheel sets were on the west side. On the right, the picture shows where we were first starting up on the east, and you can see it's a direct representation of where our total station was as we're looking at the wheel sets to give you a visual of where we are at. The summary of the results don't look good. First, the horizontal camber. That's not the problem with this crane. The horizontal camber on most wheels, we had about three wheels maybe with a little over 1 millimeter per meter of camber, and our industry standard is 0.4 millimeters per meter, and this by no means would be a problem crane because of horizontal camber. Vertical camber, however, is a little bit worse, but still I don't suspect the vertical camber as being the major contributing factor of why we have wheel problems with this crane. The wheel sequence error. This is a major area of concern. If you look at wheel set R2-6 and R2-7, you can see there that we have approximately 14 millimeters of wheel offset. That's between 2 sets of wheels, but that's like the inner set of each bogie, the split point of each set of 6 wheels. But still, that's a significant offset. You can see that the other wheels are within a millimeter of each other, going from 6.4 to 6.6, then 6.6 to 3.8, a little over 2 millimeters. Under a millimeter, right at 1 millimeter, and under a millimeter. So right here is our biggest discrepancy at that point. But then we also have a discrepancy going from these 2 wheels, 9.9 to 8.3, which isn't horrible on the millimeter per meter, on the sequence value. But the next wheel inward, it goes down to 1.2. So there we have about a difference of 7 millimeters between the set of 4 wheels and the set of 2 wheels on that one bogie set. But then again, this wheel to this wheel is only 0.4 millimeters on sequence, and then our next worst result was 4.1 to 1.6 for about 2.5 millimeters of sequence error. Looking at the upper end of the same side, beginning at R2 to R1, you can see we went through that, and that's not bad on a sequential error. On the east side, starting on the north side on rail 1, again, we're staying within just right at a millimeter until we go from the set of 4 wheels to the set of 2 wheels. And at that point in time, we have basically a 6 millimeter sequence error at that point. Then going from the 2 inner wheels, that's 3 millimeters per meter, which is much more acceptable than what we had on rail 2. So sequentially, rail 1 was not that bad. But our problem is when we have to also include the span error. Our worst set of wheels was R7 and R8 for sequence, both before and after, but coincidentally it was also the set that was closest to being the correct span. So now, does that mean these 2 wheels are your standard and you got to correct everything else to that? You know, we have to review the situation, and I'm hoping to do that. I broke these down in wheel sets. Wheel set R17 to R112. As you can see, we're right around the 460 millimeter mark, which is a half an inch basically off in span for the first 4 sets. And then it goes even worse here. So looking at this, you know, the horizontal camber on all the wheels are not considered to be significant, but the wheel span error on average for wheel sets R1 to 7 to 12 is negative 13 millimeters. The wheel sequence error between R1.8 and R1.9 is a total of 5 millimeters, which makes sense because on span we're also off 5 millimeters. So if we only had to deal with these 6 wheels, the obvious solution would be to bring him out 5 millimeters and him out 4 millimeters to accommodate our error. 6 millimeters rather than 5 millimeters. So if we brought that out 6 millimeters and him out 5 millimeters, now all of a sudden he's right around the 61, 62 millimeter area, just like these other wheels. It's closer matched. Wheel set R1.7 and R1.8, just taking in consideration those two, the horizontal camber is nearly perfect on both sets of wheels. The span error, however, is minus 16 millimeters on those 2 wheels. Wheel sequence error is 2 millimeters, so that's not real significant there. Wheel set R1.5 to R1.8, however, wheel sequence between R1.5 to R1.8 is nearly perfect. And that's up here 0.4 to 0.1 to 0.1 to 0.6. I mean, very, very straight. So that's the 2 intersets and the 2 intersets. So we feel good when we're just using these only. But keep in mind, he had to go outward, he had to go outward. So because of that, now he's got to go outward and he's got to go outward. Otherwise we'll induce a wheel sequence error there. Wheel sequence error between R2.6 and R2.6 and R2.7 is 11 millimeters. So what's the solution here? We go inward and we're going to reduce the wheel that had the best span deviation. So that's our dilemma. Do we bring all the other wheels out, or do we bring him in to make him better? Wheel sets R1, the R2-7 has 1.3 millimeter per meter camber error. Span error for both wheel sets are minus 6 millimeter of nominal span. Like I said, that is the best wheel set for span. And but because of that, they stick out like a sore thumb for the rest of the wheel sets. And here it better it illustrates that. The span goes from 66, 65 to 57, 55, 57, 55. So the wheel span is minus 16 millimeters in this entire area. So it's and then, like I said, the horizontal error is 0.4, 0.1, 1.1, 0.9, 0.3, and 1. And on this side, 1.4, 0.8, 0.5, 0.5, 0.5, and 0.2. So horizontal error, at least they're straight. We'll set R1.6 to R1.1 wheel sequence is a big concern because these 2 wheels are not too far apart, and it's a 7 millimeter sequence error. So obviously when we're improving this span by moving him out 7 millimeters and then him out 6 and him out 3 and him out 3, better aligns these wheels. Summary: the crane drawings show the span is supposed to be 42,672 millimeters. Actual span on average is minus 14 millimeters. Horizontal camber of all wheel sets are not suspected to be a contributing factor for wheel wear. Wheel sequence values are considered to be the major contributing factor to wheel wear. Challenge: find the baseline for corrective actions. Open the wheel tread to make up for the 14 millimeter span or correct bogies. Thank you.